In this video, we're going to look at some examples of equations that give us curves, and we're going to decide whether each one is a circle equation or not. So we have the general form of a circle equation stated here at the top: x minus a all squared plus y minus b all squared equals r squared. And we'll compare our equations in our examples to this and see if they're the same. If they're not, we might be able to rewrite them or rearrange them so they are, or that may not be possible. So let's look at some examples. So state with justification whether the following equations are circle equations. Example 1, x minus 1 squared plus 2 plus y squared plus 9 equals 4. Comparing to the equation, we see that the x minus 1 squared is exactly what we want. The second bracket is a little off because instead of the y term then the number, so y minus b, we have 2 plus y, so we have them the wrong way around. Hopefully we can just flip them and that'll be fine. But then we also have this plus 9. We don't want that on this side because if you look at the general equation, the only numbers outside the brackets, well, is the r squared term, which is on the right hand side. So let's try rearranging. So we have x minus 1 all squared, that stays the same, and then we have y plus 2. So I've just flipped these two numbers around. It's fine that it's a plus and not a minus. I know we have x minus a and y minus b, but a and b can be anything, so they could be negative numbers. If they were negative numbers, then when we minus them off, we get minus a minus is a plus. So y plus 2 is just the same as y minus minus 2. So that's fine, but we need to get rid of this 9 still. So we take it to the other side, and we get x minus 1 squared plus y plus 2 squared equals 4 minus 9, which is, of course, minus 5. Well, this is no good, because on the right hand side we're supposed to have r squared. We're supposed to have the radius squared. If you square a number, you get a positive number. So we can't get a negative number. There's no way of making this a positive number. So we must have r squared is greater than 0, so this is not a circle. This would be suggesting that r squared was minus 5, which doesn't make sense. So let's try a second example. We have 2 times x minus 1 squared plus y plus 17 squared equals 3. So again, the brackets look fine. What's inside them looks fine. The number on the right hand side is positive, which is fine, but we have this 2 here in front of one of the brackets. That's no good. We can't get rid of it. If we try and divide by 2, we change the other bracket. So this is a problem. Coefficient in front of the x squared term, so it's not a circle. So again, we compare this to the general form and we say it looks a bit different, and we can't rearrange it in any way, so it's no good. So 2x squared minus 2y squared equals 16. Well, what are the issues here? It's these 2's. It doesn't matter that we don't have a bracket with a number after the x and the y term. Essentially, x squared is the same as x minus 0 squared, and the same for y, so we're essentially saying that the center of this circle, AB, is 0, 0. So that's fine, but these numbers in front of the x's and y's are once again a problem. So this time, because we have the same number in front of both x and y, we can divide the entire equation by it and it will disappear. So we divide every term by 2, and that's how we're going to rearrange. We're going to divide every term by 2. And what do we get? Well, we get x squared minus y squared equals 8. We have to divide the 16 by 2 to keep everything equal. This is still a problem though, because this should be a plus. We're supposed to have an x term plus a y term, but we have a minus. There's no way of rewriting this so that it is a plus. So that's an issue. Hence, this is not a circle. So let's try one more equation. We have 2x squared plus 2y squared minus 12x plus 24y plus 8 equals 0. Very long and complicated looking, doesn't look really like a circle equation at all, but let's try and rewrite it. First of all, we'll divide everything by 2 to get rid of the 2's in front of the x and y squared terms. Once again, we can't have 2's in front of the squared terms or any numbers, so we'll divide by 2. We get x squared plus y squared minus 6x plus 12y plus 4 equals 0. So we've divided everything on both sides of the equals sign by 2. Now we need to complete the square. If you're unfamiliar with completing the square, if you're not sure what it means or how to do it, there is a video in the algebra series of videos called completing the square, which will take you through the method. But I'm just going to assume for this video that you know how to do it. So we gather up the two x terms. We have x squared minus 6x. If we want to complete the square on those, and also on the y terms, y squared plus 12y, what do we get? Well, we get x minus 3 squared minus 9. So we've gathered up the x squared and the 6x term, put them into a bracket, but then we have to minus 9 off because the minus 3, when we square it out, would give us plus 9, so we subtract it off. Similar for the y, so y squared plus 12y would become y plus 6 all squared, but when we multiplied out that bracket, we'd end up with a plus 36 term from the 6 squared, so we subtract that off too. Then we still have the plus 4 at the end equals 0. So the only problem now is all these numbers. We want them all on the right hand side. They're all currently on the left hand side. So let's take them over there. Minus 9 becomes plus 9, minus 36 becomes plus 36, and plus 4 becomes minus 4. Now let's combine them all, and we get 41. 9 plus 36 minus 4 is 41. So this now looks good. This is exactly what we want. We have x minus 3 all squared, so the a is 3. We have y plus 6 all squared, so b is minus 6. So y minus minus 6 would be y plus 6. And r squared is 41, so the radius is the square root of 41, whatever that is. So this is completely fine, consistent with the general equation, so it is a circle. So we had 4 examples, 3 of them not circle equations, but 1 of them was.
The moon burst through a mass of clouds, and she saw far off